So in this video, I'm going to talk about GXT latency debugging and using the timeline to find those issues. So to get started, I'm going to show you what I'm going to use. I've got Chrome loaded up with a simple grid. It's 100 columns wide and 100 rows deep. So that's quite a few cells to render in this grid. So let's look at the code next. We'll go to the Eclipse IDE, and I've got a simple grid constructed, and in each grid I dynamically construct a column with a cell render. And then to the cell render, I basically just add simple content saying which row and column it's on. Okay, so first, before I get to debugging latency, let's look at how it looks with rendering. So let's evaluate how it behaves without latency. So here I'm going to refresh the grid, loads the header, and renders the rows. It didn't take very long, and I've got some code to introduce some latency next. But before we do that, let's look at the dev tools, developer tools, and see what it looks like. So I'm going to go to the dev tools timeline, and I'm going to hit record and then reload the grid. And once it reloads and I see the grid, I'm going to stop recording, and there it is. I'm going to stop recording. Okay, it processes the results, and it should show me the output of the timeline and what it took. And I'm not going to go over all these features. And by the way, this process is not a black and white process for finding latency. It does take some absorption of what you see and processing, manual processing, to actually figure out what the issues are. This video should just give you a small taste of what you can do with it. Okay, so the next step is I'm going to minimize the console down here so we can see more of the stalactites let's just close the console. If we look, we can scroll over here and we have the execution timeline. Let me just select a smaller area. The yellow here, or the dark yellow, is a JavaScript execution, and purple is rendering onto the DOM. So, or browser rendering. Okay, so if I look here, if I scroll down, they're like stalactites. The execution basically, and all the, so we look at one of the method calls, and then all the small calls in the execution path. So let's say I want to find some rendering latency. This takes a little bit of sleuthing through this data to try to find. But I know in this area, if I scroll back up to the top of the execution stack, I can see do render. And within do render, since I already know the API a little bit, I know that the rows are rendered right here. So let's say I introduce latency within this do render call. So right now it's taking 94.19 milliseconds to execute this piece of code. What if I added some latency by just adding some bogus code here that does 5,000 iterations of some string replace, and then I pinned that replacement, basically it nulls out or empties out, and then I just replace a tilde. And so I'm going to comment this out. So this is only on column 5. So we'll go back to the grid. We'll reload it because Git compiles it the first time. I won't measure that piece. And we'll wait till it's reloaded, and then I'll record it again. So the grid is loading again. This time you can see it takes quite a bit longer to render this grid onto the browser, or into the browser. All right, so now that we have it loaded, I'm going to hit record. It's going to record, reload. Now it's going to take the recording, and the recording does take much longer this time. So now okay, so now the recording, I'm going to finish it. It processes it, loads the timeline. Okay, so now you can see if we look at this, it's going to be much longer. And this particular section is what I'm interested in. I can see that this is longer, and I've looked at this before I did the video, and I can determine that. So I know a little bit I have some pre-knowledge of the existence of what I was looking at. So here's column 5. You can see the tildes, it changed. Okay, so now let's just look at a section of this area. And here's do render. And if you look at do render, this time it took 1.18 milliseconds. that's quite a bit more time than it took the first time to render. So if I look at these stalactites hanging from the cave here, you can see that there's all kinds of JavaScript iteration or JavaScript calls that were added. So if I look, here's my cell construction. If I go back to the code, here's my cell construction. I just extracted a method in here. Now this might not show up depending on how the GWT compiler boils down the code, minifies it. I've got quite a bit of execution, so it kept the method and the pieces of our logic within this method. So if I go back, I can see the pieces in this method. Now, it's not a black and white process to actually evaluate this, but if you were to aggregate the code, this 31.49 milliseconds across 100 by 100 times, well, I guess would be so column 5, it would be 100 times 31.49 seconds or milliseconds. It adds up to, a bit of time, and that aggregates into, let's say, this section here. Instead of having a small section when I did it the first time, it is a large section of time. And you can see at the top it goes from 4,000 milliseconds to 6,500 milliseconds, which is about 2.5 seconds to calculate or process this data or this logic or execution path, and it adds quite a bit more time. So to drill down the fat in code, you have to evaluate it, and over a period of time, once you absorb this execution path, you can find that my cell construction is taking quite a bit of time. Now, I'm not going to go through the steps that I did to find this. I just wanted to wet your mouth with what you could do with the timeline and show how you could drill down the execution, find the fat, and cut it out. So let's say I wanted to cut this out and review the process real quick. We'll go back to the code. Okay, I know this is taking the time to render this code or execute it. So I'm going to put back the tilde just for fun and go back into the code. Well, this time it's got to compile, so I'll hit compile first by reloading the web page. Once the page renders and is ready to go, I'm going to hit record, and it's recording. I'm going to hit reload. Now we're going to see the grid render again. This time it was much faster, and we'll stop recording, process the timeline again. Once the timeline stalactites load, you can see it's between the section actually shortened from 4,000. There's some overhead in processing the code. Now this is the API code. We could improve that, of course, too. But I'm not going to talk about that today. So this section here, let's go down to do render. It's a little bit different color. Okay, so if I go down, and you can see the stalactites, there's not as many of them in the execution path. So I just cut out quite a bit of fat. The grid now renders much faster. This is kind of hard to fake a bad use case for me. But with this code gone, with this execution iteration, it renders much faster. So that concludes this video today on just how to use the basic features of the timeline to drill latency and to find the issues. Thanks for watching, and follow me for more tips and tricks, and I'll catch you later.